4-pole optional automatic transfer switch, or ATS, can indeed be utilized to transfer two single-phase feeders when you have a single generator serving as the emergency power source. The key to understanding this lies in the functionality of a 4-pole ATS, which, as the name suggests, incorporates 4 poles. These poles enable the control of two separate circuits. While the 2008 National Electrical Code, or NEC, doesn't explicitly mandate simultaneous disconnect for the normal feeder connections, it is generally considered a best practice and highly recommended for safety reasons. The rationale behind this recommendation is to mitigate potential hazards. Should one of the normal feeder connections remain energized while the generator is active, it could create a dangerous situation. To ensure both safety and adherence to the 2008 NEC, a solution is recommended. Firstly, employ a 4-pole optional ATS to manage the two single-phase feeders. Secondly, integrate a simultaneous disconnect switch on the normal feeder connections. This configuration guarantees that both feeders are completely disconnected when the generator is providing power. Let's delve into the specific sections of the 2008 NEC that are pertinent to this application. Article 210 addresses branch circuits, focusing on the requirements for electrical circuits extending from the final overcurrent device protecting the circuit to the outlets. Article 210.8 covers ground fault circuit interrupter, or GFCI, protection. It details the specific locations and situations where GFCI protection is required to enhance safety and prevent electrical shock hazards. This includes bathrooms, kitchens, garages, and outdoor locations. Article 210.12 discusses arc fault circuit interrupter, or FSI, protection. It mandates the installation of FSIs to protect branch circuits supplying dwelling units to reduce the risk of electrical fires caused by arcing faults. Article 210.19 outlines the conductor ampacity requirements for branch circuits. It specifies the minimum size of conductors based on the circuit's overcurrent protection and the type of load being served, ensuring safe and reliable operation. Article 210.20 focuses on overcurrent protection for branch circuits. It details the requirements for selecting and installing overcurrent devices such as circuit breakers and fuses to protect conductors and equipment from overloads and short circuits. Article 210.21 covers the permissible loads for branch circuits. It specifies the maximum load that can be connected to a branch circuit based on its ampacity and the type of load, preventing overloading and potential hazard. Article 210.23 outlines the permissible loads for specific branch circuits, such as those serving lighting outlets, receptacles, and appliances. It provides guidelines for determining the appropriate circuit size and type for different applications. Article 210.24 presents a summary of branch circuit requirements, providing a table that summarizes the key requirements for different types of branch circuits, including their voltage, ampacity, and permissible loads. Article 215 pertains to feeders. Feeders are the conductors that carry electrical power from the service equipment to one or more branch circuit overcurrent devices. Article 215.1 covers the scope of Article 215, which applies to feeder conductors. It specifies that the requirements of Article 215 are applicable to all feeder conductors, regardless of their voltage or application. Article 215.2 addresses the minimum size of feeder conductors. It requires that feeder conductors be sized to carry the calculated load, based on the connected branch circuits and any applicable demand factors. Article 215.3 outlines the requirements for feeder overcurrent protection. It specifies that feeders must be protected against overcurrents by circuit breakers or fuses sized to protect the conductors from damage. Article 215.5 covers the requirements for feeder grounding. It requires that feeders be grounded in accordance with the requirements of Article 250 to ensure a safe and effective ground fault path. Article 215.6 addresses the requirements for voltage drop in feeders. It recommends that voltage drop in feeders be limited to 3% for power, heating, and lighting loads, and 5% for feeders serving motor loads to ensure proper equipment operation. Article 215.9 outlines the requirements for ground fault protection of equipment for feeders. It specifies that ground fault protection is required for feeders serving certain types of equipment, such as service equipment and large motors, to reduce the risk of electrical shock hazards. Article 404 focuses on switches, including their installation and use. Article 404.2 addresses the requirements for switch connections. It specifies that switches must be connected so that the switching occurs only in the ungrounded conductor, ensuring that the grounded conductor is not interrupted. Article 404.3 outlines the requirements for enclosure types for switches. It specifies the types of enclosures that are permitted for switches in different locations based on environmental conditions such as moisture and dust. Article 404.4 covers the requirements for switch ratings. It specifies that switches must be rated for the voltage and current they are intended to control to ensure safe and reliable operation. Article 404.8 addresses the accessibility and grouping of switches. It requires that switches be readily accessible and grouped together where practicable to facilitate operation and maintenance. Article 404.14 outlines the requirements for the number of switches required for different applications. It specifies the number of switches that are required for lighting circuits, appliance circuits, and other types of circuits to ensure adequate control and safety. Article 702 pertains to optional standby systems. These systems provide power to specific loads during a power outage, but are not legally required for life safety. Article 702.4 covers the transfer equipment requirements for optional standby systems. It specifies that the transfer equipment must be suitable for the intended use and must be designed to prevent the unintentional interconnection of the normal and standby power sources. Article 702.5 addresses the capacity and rating requirements for optional standby systems. It specifies that the standby power source must have sufficient capacity and rating to supply all connected loads simultaneously. Article 702.6 outlines the wiring requirements for optional standby systems. It specifies that the wiring of optional standby systems must comply with all applicable requirements of the NEC, including those for overcurrent protection, grounding, and wiring methods. Article 702.7 covers the equipment installation requirements for optional standby systems. It specifies that the equipment must be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Therefore, to reiterate, using a full-pole ATS with a simultaneous disconnect switch provides a safe and code-compliant solution for transferring two single-phase feeders to a single generator during a power outage, while adhering to the guidelines outlined in the 2008 NEC. Remember to consult the latest edition of the NEC and local amendments for the most up-to-date requirements, and always consult with a qualified electrical professional for specific installations.